and we want to look at the idea of trigonometry. And how it's related to similar triangles. Okay, and so if we look at our assignments for today, finding the value of a relationship. Okay, so let's see if we can find that. But basically, we want to see how once you had similar triangles and understood that you could move on to trigonometry. And that's what we want to think about right now, is that relationship. Find the value of the relationship. Is that really what we're looking at? Oh, the homework. Yeah. Okay. So here we are, and let's suppose you were in this situation that you wanted to measure the height of this tree, okay? And you knew about similar triangles, and you said, well, here's a right triangle. So what I'm going to do is I'm going to take a meter stick, so 1 meter. Okay? I'm going to create a similar triangle. So I'm going to go back. And then I'm going to put my hard part. I have to put my head on the ground. Okay, so you're going to see different things where maybe you try and be 1 meter high or something like that, right? So you could try that as well. So think about that, right? And so if I draw a straight line, you say, oh, there's similar triangles. And I know this is 1 meter, and I can measure this. And let's say that it was 2 meters. Okay. And so what's your similar triangle? So you say, okay, the ground to the vertical. So the vertical and horizontal is 1 meter to 2 meters. And then we walk this off. We can walk this off, and we say, okay, and that's 30 meters. And so the tree must be in that same proportion. Okay. But what you'll notice is that the ratio is going to always be the same for that particular angle. Let's see, I think, yeah, that's from took a while to retrieve that. So theta, for an angle theta. Remember from physics class. So the angle for theta in degrees, right? That's anytime you have that ratio, you're always going to have that same angle. Okay, so what do we do then? So now we can save ourselves some work, right? Is that we can save ourselves some work by not having to have the ratio anymore. So if we know this angle, we don't really need to care about that. All we need to do is walk off the length. So we say, okay, here's the angle, and the angle must be equal to the ratio of the vertical to the horizontal. Okay, so another way of thinking of it is that we found this ratio before, and now we said, no, if it's easier to measure the angle, then we just know the angle, and we know that, but we still need to know one of the sides, right? Still need to know one of the sides. Okay, so we still have to walk this one off, walk off that one, but if we know the angle, we say whatever that percent is, so like we think it's 0.5 is going to be what we need to do. So that's the essential knowledge you need to have, is this understanding of, well, where did trigonometry come from? And why is it so much easier? Well, so you store up this knowledge. You say, I've got this knowledge of what the ratio is when I have a particular angle. So now I don't have to use similar triangles anymore. I've got the knowledge from the similar triangle is already with me, and that's what I'm using. Okay? In our homework, we're going to actually work on using Wolfram Alpha. And so what we want to get is the idea that in real life, nobody does trigonometric computation. So the reason that you get paid is because you know how to set up, you understand the relationships. The calculation gets done by the computer. And so this is something that isn't part of your education because unfortunately the education you have is a little bit behind the times. If you watch the movie Hidden Figures, okay, really worth watching. Okay, so on the one hand, worth watching because of discrimination uh, against these African American women who worked for NASA. But the fact was that even for the first space flights, they used people with pencil and paper to do their calculations. Now, of course, if you think about it, there's nothing done on paper and pencil anymore. The Mars landing and stuff. When you fly in an airplane, the plane's really flown by the computer. There's a human being there in case something goes wrong, but even the landings and takeoff are run by the computer because the computer is doing these calculations. And the idea is that when you write a program, it's wrong, okay, but once you get it fixed, it'll run correctly again and again and again. A human being, every time they do a calculation, there's a chance that they'll make an error. And so you sort of put your errors in up front, and then you have this reproducibility from the computer. And so that's the idea that we want you to get, is that we work on our on our programming the equation to solve these problems, and then once you have it working, you can put in again and again into what's worked for you and have that.